Next topic is electronic configuration. Electronic configuration. This is next topic. We know that electron configuration, that is what 1s2 2s2 2p, like that electron configuration is there for all elements, but we don't know the definition. So here the definition is filling of electrons in the orbitals. Filling of electrons in the orbitals is called electronic configuration. Filling of electrons in the orbitals is called electronic configuration. There three rules are there where to fill the electrons in the orbitals we have to follow three rules. They are Aufbau principle, Hunds principle, Paulis principle. Aufbau, Hunds, Paulis principle. Now we have to discuss about those three. These are very important. See, in case of Aufbau, what is the definition? The electrons enter into lower energy orbital first and higher energy orbital next. That is nothing but electrons enter into increasing order of energy level. This is one more statement. What is the statement here? The electrons enter into lower energy orbital first and then enter into higher energy orbital next. That means electrons first enter into lower energy orbital, then enter into higher energy orbital. That is also called electrons enter into increasing order of energy level. Increasing order means lower to higher. So that is the statement. That was the statement given by Aufbau. Here we have to know one more point, that is, what is the energy of the orbital? How can we find energy of the orbital? We have to know that point. So the energy of the orbital is calculated by n plus L value. That is given. See, the energy of the orbital is calculated by n plus L value. For example, for 1s, I told you already, these numbers indicates n values. So for 1s, n value is so much? 1 plus L value 0. 1 plus 0, 1. For 2s, 2 plus 0, 2. For 3p, 3 plus 1, 4. For 4s, 4 plus 0, 4. So that is the way to calculate energy of the orbital. That means by using n plus value, we can calculate energy of the orbital. Next, if n plus L value is same, then the electron enters into orbital having lowest n value. This is very important point. See, in this 3p and 4s case, n plus L value is same. So in such case, electron will enter into which case? The orbital which is having less n value. Then electron enter into that orbital. See, in this case n value is 3, in this case n value is 4. So that electron will enter into first 3p. After filling 3p, 4s will come. Suppose for example, take potassium. What is the electron configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. That means after completing 3p, 4s will come. Even though n plus L value is same, but why 3p prefer in that case? In that case n value is less. So when we should consider that statement, if n plus L value is same, then the electrons enter into orbital having lowest n value. Next, that is about Aufbau rule. Next, Hund's rule. What Hund's rule says? Pairing of electrons takes place. When each orbital having one electron. That is called Hund's rule. Pairing of electron takes place when each orbital having one electron. I will discuss one example, then you get idea. See, for example, take nitrogen atom. Nitrogen atom electronic configuration 1s2, 2s2, 2p3. 1s subshell contains only one orbital. So this box indicates orbital. 2s, any s contains one box. P contains how many? 3 orbitals. That means 3 box. It contains 2 electrons. It contains also 2 electrons because 2 present. Here 3 electrons. These 3 electrons should be mentioned in different orbitals. That is the way to fill the electrons. We should not fill 2 electrons here and 1 electron here. First filling the electrons enter into each orbital. After completing each orbital, then only pairing takes place. Suppose take oxygen. Here electronic configuration 1s2, 2s2, 2p4. Same here 1s2, here also 2s2, same configuration takes place. But in 2p4, how many electrons? In P4 electrons are present. There are 1, 2, 3. Here up to here each are filled. Then pairing takes place. That is the meaning of that statement. So what is the point? Hund's rule. Pairing of electrons takes place when each orbital having 1 electron. Then only pairing takes place. That was the statement given by Hunds. Next, Paulis principle. Paulis rule. Here what he said, no 2 electrons in an atom having same 4 quantum numbers. That is very important. No 2 electrons in an atom having same 4 quantum numbers. That is the statement regarding Paulis principle. That means if one electron having 4 quantum numbers, those 4 quantum numbers will not be equal to any other electron in that atom. I just repeated that point once again. If one electron having 4 quantum numbers, those 4 quantum numbers values will not be equal to any other electron in that atom. That is the meaning of that point. For example, take helium. Helium atomic number 2, its electron configuration 1s2. So this is the way to mention electronic configuration. This is orbital representation. See, the first electron, this is clockwise electron. Second electron, this is anti-clockwise electron. Now we are going to write NLMS values for this electron, first electron. This is present in 1s2, so that n value is how much? 1. Here s orbital, for s orbital L value is how much? 0. If L is 0, automatically M is also 0. Why? M value depends on L value. Those values from minus L to plus L. Already L value is 0. There is no chance of minus, so M value is 0. This is clockwise direction, so that S value is how much? Plus of. Those are the NLMS values for first electron. Now for a second electron, N value is how much? 1, because that is also present in 1s2, this orbital. L value 0, because for s orbitals L value 0. Again M value is also 0, because M value depends on N value. For this S value is minus of, because this pairing electron is what? Anti-clockwise direction, so that S value is minus of. If you observe these 2 electrons values, NLM value is same, but S value is different. If one value is different, automatically that electron also will be different. So what we have to understand, these 2 electrons are not having same NLMS values. These 2 electrons are not having same NLMS value. So that was the statement given by Paulis principle. So this is all about electronic configuration. Here statements are very small statements, but concept is very important. You may get this type of model in competitive level. In competitive level, sometimes you may face this type of model in CBS level also. See, this is 1s, this is 2s, this is 2p. Sometimes they may give the question like this. This type of boxes are given. That configuration, that means this is what? Orbital configuration. This is orbital configuration. I think that electronic configuration. In this case, what is the question? This configuration obeys Aufbau or not? Obeys Hunds or not? Obeys Paulis or not? That is the question. Suppose first take Aufbau, whether it obeys Aufbau or not. See, one is any orbital maximum contains 2 electrons, but here only one electron is present. Without filling 1s orbital, electron jumps into 2s orbital. That means electron, what Aufbau statement? Electrons enters into lower energy level, then enters into higher energy level. Without filling completely electrons in s subshell, electron enters into 2s subshell. That means it does not obey Aufbau, it violates Aufbau rule. Next, Aufbau principle, it also does not obey Aufbau, Hund's rule. Why? See here, what Hund says, pairing of electrons takes place when each orbital having one electron. Here only one electron is present. Here pairing does not take place. Without pairing, just electron enters into 2s. So Aufbau and Hund's does not obey this configuration. But paulis obeys. Why? What paulis says? No two electrons in an atom having same 4 quantum numbers. If you calculate anonymous values in this case, all electrons will be getting different quantum numbers. So that it obeys paulis. Next, here, second example, 1s completely filled, 2s only one electron is there. Actually 2s having maximum capacity of 2 electrons, but only one electron is there. So that Aufbau and Hund's both are not obeyed, but paulis obeyed. In third case, 1s 2 electrons, 2s 2 electrons, 2p see 4 electrons. But here you have to observe one point. Here pairing takes place. You may think that pairing starts from here, but after filling the electron, after completing third orbital, electron can occupy any orbital. Pairing of electron occupy any orbital, either px or py or pz. But we usually write from starting. But pairing of electron can takes place either px or py or pz. That is why paulis, all both everything obeyed. In last case, see here 2 electrons is present in same spin. Here 2 electrons are present in opposite spin. Here only one electron is there. If 2 electrons are present in same spin, automatically those 2 electrons having same quantum numbers, automatically that does not obeyed by paulis. But Aufbau and Hund's obeyed. How? Here what Aufbau said? After filling lower energy, higher energy orbital will be filled. So here 2 electrons filled. Then again it goes to 2s. That only Aufbau says. And Hund's says what? Pairing of electrons takes place. Here pairing takes place. So that Hund's also obeyed. Here you may get one doubt here. That is what? Here one electron is present in middle of the box. That means after completing 2s, electron directly enter into second orbital of the 2p subshell. That is also correct. We usually write from here. After completing 2s, electron directly enter into either of the orbital, because before entering this electron, all orbitals having same energy, all empty orbitals having same energy, so that electron can enter into either of the orbital. But we usually write from starting. So this is also correct. So in this case only paulis not obeyed. Why? Because in this case 2 electrons having same spin. If 2 electrons having same spin, automatically those are having same set of quantum numbers. That will be wrong according to Pauli. So this is all about electronic configurations. Next one, last topic is there, that is anomalous configuration of chromium. Anomalous configuration. Anomalous means different. So different configuration of chromium. See, what is the expected configuration of chromium? Argon 4s2 3d4, because before chromium vanadium is there. Vanadium electronic configuration is what? Argon 4s2 3d3. Then we think that after vanadium 4s2 3d4 will come. We think like that. But what happens? One of the electron in 4s orbital jumps to 3d orbital. In that case, then what happened? 3d subshell having half filled. Half filled means if that subshell contains one electron in orbital, one electron in each orbital, then that will be half filled. If an atom having either half filled configuration or completely filled configuration, that will be more stable. So what is the point here? Here one of the 4s electron jumps from 4s orbital to 3d orbital. It leads to more stable for chromium due to half filled configuration. So finally the configuration is what? 4s1 3d5. So this is the electronic configuration for what? This is the electronic configuration for 4s2 3 4 1 2 3 4 electrons. This is the electronic configuration for what? Chromium. When this electron is configuration is present, then it is half filled configuration, then this will be more stable. That is why electron will not be second electron will not be present in 4s orbital. That happens in case of chromium. In case of copper also same phenomenon takes place. What is the expected configuration of copper? Expected configuration of copper is argon 4s2 3d9, because before copper nickel is present. What is the electron configuration of nickel? 4s2 3d8. So that in copper we think that 4s2 3d9 will come, but what is the configuration of copper? 4s1 3d10. Why? One of the electron in 4s orbital jumps to 3d orbital, then 3d9 becomes 3d10, then it will be completely filled configuration. This is half filled. When subshell contains one electron, that is half filled. When subshell contains two electrons, this is subshell, then that will be completely filled. When atom having either half filled or completely filled, that will be more stable. So because of this reason, this configuration does not exist, this configuration exists. So one of the electron in 4s orbital jumps to 3d orbital to it's more stable for copper due to completely filled configuration. That's all. So this is all about anomalous configuration, and this is all about structure of atom. Thank you.